Today we are going to talk about the atmospheric pressure. Okay, so the concept of atmospheric pressure is very simple. The pressure which is applied by the air molecules, or the pressure which is applied by the atmosphere or any body, right? Just like if we are just sitting, or if anybody is at rest state, or if anybody is moving or is in motion state. So normally what happens, let's suppose if we are just in rest state. So normally we are breathing, or our breathing is very normal, like just like the other people's, those who are in rest state. But let's suppose if all the other one are in rest state and you are running at some specific point from one point to another. So you observe that your breathing is now like different from the other. You are breathing more faster as compared to the other people, right? So why this actually happen and what is the reason behind it? Because there are some other features that is related to your body also, but we are only talking about the physical change that is actually happened over there with the surrounding or with the atmosphere. So the main factor is related to the atmospheric pressure. So we are talking about the atmospheric pressure. So first of all, if we want to write the basic concept related to the atmospheric pressure, so we can say that it is just like the same reference for the liquid molecules. Same goes for the air molecules because that is related to atmosphere. So it is the actually the force applied by, or the force exerted per unit area by the surface, or we can say that by the air molecules on a specific surface, right? We can write it like this: force per unit area exerted against a surface by the weight of air above the surface. Okay, so don't get confused in the definition, because this is very a common example. Let's suppose if you consider your body, right? So our body, there is also some surface area of our body, right? Let's suppose if we consider our body from the front side, like from the top side of our body to the bottom, like to the feet. So there is some specific area, right? So now when you start to walk from one point to another, and when you start to walk from one point to another, so you observe air molecules are actually striking your body, right? So actually that is the concept of atmospheric pressure. Because when you start running or when you start moving, so you are going to observe that air molecules are actually colliding with your body. So that is the concept of atmospheric pressure, because air molecules are applying force on your body, on the surface of your body. Okay, so this is the very common example, very basic concept of atmospheric pressure. And one more question might be that in your mind, that why we don't feel atmospheric pressure when we are in rest state, right? Let's suppose if you are sitting in front of air cooler, or just like in front of the fan, right? So you observe air molecules also, right? Your hairs are just waving in the air, and clothes are just waving in the air. So why this happen and why that will not happen in the normal state? So actually in normal state, the air pressure inside our body, sorry, the pressure in our body is equal to the air pressure outside the body, right? So both the value of pressures are equal. So that's why we don't feel pressure in normal state. And when we start running, and when we start jogging, or when we are driving a car, or just riding a bicycle, so you observe that air pressure, because now air pressure or atmospheric pressure is greater on your body. So that's why it will be difficult to breathe in that situation, and that's why your breathing process will be different when you are running from one point to another. Okay, so that is the main difference, that why we don't feel pressure in normal condition when we are sitting in a room, and why we feel atmospheric pressure or the force by the air molecule when we are running from one point to another. Okay. Next thing is that let's suppose if we want to identify, or if we want to find out that how atmosphere, or what is the proof of that atmospheric pressure, right? Because we discussed this example, okay, that is fine, but we still need some physical proof, or like experimental proof that actually proves the atmospheric pressure in our daily life. Okay, so for that we have a very simple experiment, that what we need to do, we need to take a very shallow tub. Let's suppose if we take a very shallow tub. Okay, and we just fill it with water or any liquid. We filled it with water at at certain level, and what we need to do, we need to take a test tube and place inverted into that tub, like this. Okay, so we just take like test tube and we just place inverted into that tub. So what actually happen, if you do this experiment in your daily life, like if we just take a mug and just try to place that in inverted form into the bucket or into any surface of water, so you observe that water is actually applying force, and water is start filling in that mug inside the mug, right, rather than increasing in the outside or increasing in the outer area of that mug. So normally what happens, we know that atmospheric pressure is there in atmosphere, and air molecules are actually applying pressure on any surface. So let's suppose you observe that from left and right both sides are open for air. So actually air molecules are applying force on the water molecules, right? And the test tube which we placed inverted into the water surface, so that is completely vacuum in it, right? So there is no air in it.
Wait, how?
Okay. Now that is important question, how? Because we are having air molecules all around us. So very simple process, just fill that test tube with water. Okay, so now there is only air molecules. Just make sure there will be no air bubble,
Ah, okay.
and just invert that tube into that tub, right? So that's why we just fill at certain level, because we also have some water in the tube. And when we just invert that tube, so there will be vacuum inside the tube when there is no water at certain point. Okay, so
Okay.
this water level will fill in the tube at certain level, let's suppose, because we are just making the diagram and we are just talking about the concept, we are not performing the real practical, because previously it is included in your syllabus in very much detail, but now it is not much included in detail, so that's why we are not working in the proper specification. So this is the level of water that actually fills in the tube. You can see that some part of the tube having a vacuum, because initially when tube is in normal condition, so completely it is filled with water, and when we place inverted, so water will also add into the tub, but due to atmospheric pressure, some water still remains in the tube, and remaining part of the tube just contains vacuum right now. Okay,
So can you show a video?
I will also share the video that how actually this perform in the real life. So what is the concept and how we are going to find out the pressure right now. So that height in, or that height of liquid in the tube actually gives you the same concept of depth, right? Because we previously discussed the pressure in liquid. So this depth will also give you the concept that how to find out the atmospheric pressure with the help of this water surface and the water level. So the thing is that when we invert the tube, so according to the atmospheric pressure, water will remain in the tube. Otherwise, what happen? Due to gravity, all water should be added into the tub, right? Because we know there is also a force of gravity which actually acting in the downward
Yeah.
direction. But due to atmospheric pressure, you observe that when you place or when you try to immerse your hand into the bucket, so water it starts to increase level in the bucket, and at certain point it is start to flowing outside from the bucket, right? Because you are adding extra matter into that water level. So same thing is going over here when air molecules try to push that water surface. So water is going to be increased in the level of vertical tube or that test tube which is placed vertically inverted on the water surface. Okay, till now it is clear? Any confusion?
No, sir.
Okay, and this uh, setup is actually known as mercury barometer, right? Last time I show you some topics from your syllabus that is included in your pressure. So there is a topic that only discuss that how height will help you to find out the atmospheric pressure, right? So that is the topic, and there is also a name of barometer. I will also share, or you can check from your syllabus also, that there is a topic related to that discuss that how height will help you to measure the atmospheric pressure using barometer, right? So this whole setup or this whole apparatus is known as barometer. And for the ideal condition, we use mercury rather than water, right? Because we also use mercury in thermometer. What is the reason we use mercury? That
Favorite
topic is,
answer?
yes, because it is not like the sticky one, just like the normal water, because water remains stick to the wall, right? So that will not give you exact value of atmospheric pressure. So that's why we used to take mercury. And we know that the boiling point of mercury is very much high. So if the temperature is high in your surroundings, so water will not evaporate. Sorry, mercury will not evaporate, water will easily evaporate, right? Because evaporation is a natural process, it can take place at any temperature. So for ideal condition, we take mercury as a liquid in it. So that's why this setup is known as mercury barometer, and these green lines shows you the concept of the pressure exerted by the air molecules, or the force exerted on the surface by air molecules. So this is the concept. Let me show you practical demonstration of this atmospheric pressure setup. I hope this is not very difficult, right? Because we are not able to observe the air molecules, so that's why it's sometimes very difficult to understand the concept of the atmospheric pressure. Because in new syllabus pattern, many topics were excluded, so that's why we only discuss about some specific terms. Okay, so we are having apparatus like this because we know that if we take test tube, so a test tube is like a very thick one and we need to fill very high quantity of mercury in that. So sometimes we just take a capillary tube, a very thin tube, just like the tube that this lady is going to be using this experiment. Now you can see there is an opening in the tube, right? And she is filling the mercury in it. You can see that mercury is in the metallic silver color
Okay.
because mercury is a metal, but this is the only metal which is in liquid form. You also studied that in chemistry, right?
Yeah.
And it like the heavy one when you just fill some of liquid or some of mercury in a very small quantity, because this is metal, so that's why it is very heavy. So we also take a very little quantity, otherwise it will break the glass or it will just damage other things. So that's why we are using a very thin tube for this purpose. Now you can see that mercury is completely filled, so there is only liquid in the tube, no air in it. Now to make it inverted, we just place finger at the bottom side or at the open face of that tube. So that's why no mercury is going to be coming out from that tube. And you can see he placed into the container that is already filled with the mercury, right? Okay, one more
Yeah.
important, that we don't need to touch the opening of that tube with the base, right? Because you know that if you touch with the base, so mercury will remain in the initial state, like the complete tube is filled with the mercury, because there is no opening for the mercury to come out from
Yeah.
the.
To move. Yeah.
So that is the condition. So now you can see that some of the mercury actually moves down because it is completely clamped with that iron stand, right? And you, if you observe that previously she just make in contact with the base because he need to place and fix that with that iron clamp, right? But it is not coming out from the surface of that mercury, right? You can see that because
Yeah.
once it completely out from the surface, so all mercury is going to be added into the that flask or that in container. So some mercury actually moves down and added into the tube or that container that we are using. And if she again shows you that, yes, she is also going to show you the height. Now you can see the height. So this is 744 millimeter. Actually, this is the classical experiment, and this is the classical example and the classical experiment that how first time someone used to use the apparatus to find out the atmospheric pressure, right? So this is the ideal value 744 millimeter. If you get this specific height of 744 millimeter, so it means that this is the ideal situation, this is the ideal condition to find out the atmospheric pressure in room temperature, right? We are working in room temperature, we are not working in very high temperature or in very low temperature or like very different situation, right? So at room temperature, or we can say that at sea level, so the height of the liquid in that barometer will be equal to 744 millimeter. Okay,
Mm-hmm.
because on a scale you can see it is 74 because that is in centimeter, right? So this is the experiment, right? Now you got the concept, and you can also see that mercury is now at very low level. Mercury is not now completely filled. So most of the tube got
Uh-huh.
empty during that experiment. So that is due to that atmospheric pressure.
But it won't fully get empty because the atmospheric pressure is still pushing it backwards.
Yes, because it depends upon the atmospheric pressure. If atmospheric pressure is very much high, right? So it will be like it just start pushing the water molecules, and always water is coming out from the container, right? Because as I already discussed that in normal state, the internal pressure is equals to the external pressure, just like our body. We are breathing, so there is also a pressure on our lungs, right? When we just inhale and when we exhale, so when we inhale, so what actually we are doing, we are decreasing the pressure inside the lungs, right? Just like the
Uh-huh,
pump
okay,
that
okay.
we use to fill the air. And when we are exhaling the air, so we are creating the pressure outside the lung, and we are decreasing pressure inside. Okay.
Okay.
So when we increase the pressure, so volume will decrease. And when we decrease the pressure, volume will increase. A very daily common life example of the breathing, right? So same goes over
Yeah.
here. Because when pressure increases, so your volume actually decrease in the tube, and mercury is added into the container that we placed in the base of that tube. Okay. You can see that there are different level. Might be they take in different conditions. Okay.
So what's that?
Actually, this is also a tube, but in, we can say that, different orientation, not in vertical direction. Okay.
Ah, okay.
Now you can see that it is also at the same level, right? Slightly there is a difference because she is just showing you with the hand, so there is a shaky position. But still, if you are performing this experiment in irregular shaped tube, so again it will remains the same pressure, right? Because atmospheric pressure will remain same everywhere on everybody in normal condition. Okay, I hope that now there will be no confusion.
Sort of confusion.
Okay, so this is the experiment, because only confusion is that that how we just create vacuum in the tube, and how this all experiment will go on for the atmospheric pressure, right?